Now, relation between alpha and gamma. What is alpha? Alpha is coefficient of linear expansion. Gamma is coefficient of volume expansion. Right. How to take the relation and what we have to prove? We have to prove gamma is equal to 3 alpha. So let us consider a simple cube. Then you can a cube of volume V. Let us say a side of L. So volume is L cube. Volume is L cube. On heating, what happens? There is a change in length is observed, right? So here delta L is directly proportional to delta T. So length on each side, length can be increased. That becomes L plus delta L. So imagine this is a cube of length L that expands equally in all directions when temperature raised by delta T. Right? Now, how to calculate delta V? Of course, delta V proportional to delta T. Delta V is equals to change in volume. Change in volume. How to write change in volume? Expanded volume minus original value. What is the expanded length? L plus delta L. What is the original length? L. So expanded length cube, that becomes expanded value minus original volume delta V. This is now expanded, you will get it delta V is equal to A cube plus B cube plus 3A square B plus 3AB square minus L cube. L cube getting cancelled. So what you will write it as? Delta V is remained with delta L cube plus 3L square delta L plus 3L delta square. These are remain. Right? Now here delta L is a small quantity. So delta L cube, delta L square can be neglected, cannot be considered, discarded. Can be neglected. Now how do you write now? This is not considered. Delta V is equal to 3L square delta L. right? Now, shall I write like this? Delta V is equal to 3L cube delta L by L multiplying dividing with this one. Delta V is equals to, what is L cube? L cube is volume. What is this one? Delta L by L, as it is fractional length L, right? Shall I write like this? Delta V by V into, I am taking delta T here, so 3 into delta L by L 1 by delta T, dividing on both sides with delta T. Now what do you write actually? We can write delta V by V into delta T is gamma is equal to 3 into delta L by L into 1 by delta T is alpha. So coefficient of volume expansion is equal to 2 times of coefficient of linear expansion. On the other hand, we also write like this. What is beta? Beta is equal to 2 alpha. What is gamma? 3 alpha. What is the ratio? B by gamma is equal to 2 by 3. Beta by gamma is 2 by 3. So whenever the relation between alpha beta is there, alpha gamma is there. Now beta gamma, if you want, this is a simple relation. In the problems, it will be helpful actually. Now how to write the expression for thermal stress. Let us consider a simple rod, a rod of length L. Think of that this rod of length L is fixed between two rigid supports. Rigid supports. Now on heating, what happens? On heating, the rod is trying to expand. The rod is trying to expand. But what these rigid supports are doing to not to expand like that. So compressive. There is a stress is applied on the rod by the supports even it is being heated. So there is a stress is called as compressive stress. There is a stress is called as compressive stress. When this is heated between the two ends, the rod acquires compressive strain due to external forces provided by the rigid support, which are at the ends. The stress is called as compressive stress. Of course, this if this is made up of steel, which has Young's modulus, right, and there is an area which is also there, right. Now Young's modulus formula Y is equal to stress by strain. Stress by strain. Right now, if you want to calculate this stress, is F by A is equal to Y into delta L by L. What the stress actually, how this is happened, due to heating it is happened. This stress is called as thermal stress. This stress is called as thermal stress, which is equals to Y into delta L by L. Right now, thermal stress is equal to Y into delta L by L. Shall I multiply and divide delta T by delta T? Right now, thermal stress is equal to Y into delta L by L 1 by delta T into delta T. What is this? This is called as alpha. Thermal stress is equal to Y into alpha into delta T. Right now, that what the force that has been acted on the rod on heating by the ends, force F by A actually here, force is equal to Y into A into alpha into delta T. So this is actually force acted by the ends. Here a problem, a blacksmith fixes an iron ring on the rim of the wooden wheel of a bullock cart. The diameters of iron ring are rim and iron ring are 5.243 meters and 5.231 meters respectively. What the temperature? Initially temperature is 27 degrees. So T1 is equal to 27 degrees. So to what the temperature? So T2 has to be calculated. Should the ring be heated so as to fit the rim of the wheel? What is the final length? What is the initial length? This is actual diameter and this has to be expanded, this one. L1 is equal to 5.231 meter. L2 is equal to 5.243 meter. So delta L is equal to L1 alpha delta T. L2 minus L1 is equals to L1 alpha T2 minus T1. So how do you write this? We want to get T2 minus T1. So L2 minus L1 by L1 alpha. I want to get T2. T2 is equal to T1 plus L2 minus L1 by L1 alpha. Substitute the values, then you will get the answer. T2 is equal to T1 is 27 degrees centigrade plus L2 5.243 minus 5.231 by L1 5.231. What is alpha? Alpha is not given. What is that? Iron. Iron rim is that, right? So we have to write alpha for that value. So alpha for the iron rim is equals to 1.20 into 10 power minus 5 per degree centigrade or per Kelvin. So T2 is equals to 27 plus 5.243 minus 5.231 by 5.231 into 1.20 into 10 power minus 5. Substitute all the values and get the answer for final temperature. And doing all calculations by using a calculator, approximately you will get it as 218 degree centigrade. Now we enter into the concept called as what is heat capacity, how to define what is meant by specific heat capacity, and what is meant by calorimetry and calorimeter. So we'll define these, right? Now, of course, we also see principle of calorimetry also. When we take the water in the vessel, when we take the water in the vessel and heat for some time. Now, what is our observation? The observation is after some time, they are called as bubbles will be observed. Bubbles begin formed, and that is called as a turbulence. There is a turbulence can be appeared on that. Yes or no? Right? Now, as the temperature is increased continuously, when the temperature is increased, what happens? The turbulence can be also increased and it starts boiling. It starts boiling. And this is about water I was said. Now coming to a liquid which you change it, mustard oil, and heat it. Suppose initially they were at 20 degrees centigrade. You want to make it like 40 degrees centigrade. What is the time taken for to raise the temperature by the 20 degrees centigrade from 20 degrees centigrade to 40 degrees centigrade? What is the time taken for water? And similarly 20 degrees centigrade to 40 degrees centigrade, what is the time taken for mustard oil? Let us say another oil, not mustard oil. Do you observe that the timings to raise the temperature difference by 20 degrees are same? The answer is no. Some are quickly heated, some are slowly heated. So time is different for different substances to raise the same temperature or to get the temperature difference as same. Right? Now that is dependent on nature of the substance. The quantity of heat or the amount of heat is required to heat the given substance on its mass m. The change in temperature delta T is called as heat capacity. Let us say Q. What is that Q? Q is equal to, sorry, let us say H, which is heat capacity H. H is equal to delta Q by delta T. Delta Q by delta T. What are the units actually? Unit is joule per Kelvin. If you take suppose 2 kg oil, if you want to increase the temperature difference of 40 degrees centigrade, let us say, the amount of heat supplied is called as heat capacity. Based on the heat capacity, as his heat capacity is increased, right? Now temperature difference you can get it, right? So delta Q by delta T means delta Q here called is equal to H into delta T. So H is a material. It is different for different materials also. We will also write in other terms when a given quantity of heat is absorbed or rejected by it, right? It is characterized by a quantity is called as heat capacity, right? This is one another alternative form of definition. We will see a specific heat capacity and we also solve some problems on it. So now specific is a particular, right? Every substance has the unique value for the amount of heat actually, for the amount of heat, whether it is absorbed or rejected. To change the temperature difference, to change the temperature difference of 1 degree centigrade of 1 unit mass and 1 unit mass means let us say 1 kg. is known as specific heat capacity, right? Means the amount of heat is required to change the temperature difference or raising of temperature of the substance by 1 degree centigrade, where we consider that amount of the substance is taken as 1 kg. Let us say 1 kg copper slab. Earlier it is 37 degree centigrade. Now take same that copper again, 1 kg substance, you make it 38 degree centigrade. What is the difference is there? Temperature difference is this one. The amount of required to change this state to this state, which is called as S, which is called as specific heat capacity, right? Now how to write the formula? Specific heat capacity is equal to 1 by m delta q by delta t. 1 by m delta q by delta t. What are the units for specific heat capacity? Joule per kg per Kelvin. This specific heat capacity is different for different values. Means it is different for earth, it is different for water, it is different for copper, it is different for aluminum. So it is individual values are there. They are fixed. They cannot be changed time to time, right? So generally water is, it is 4186 or 4200 joules per kg per Kelvin. Generally it can be taken, right? Now what is meant by molar specific heat capacities? Simply nothing here. You can use, instead of 1 kg you can use 1 mole, that's all. The amount of heat is required, right? We will write it in the form of the amount of heat is required to raise the temperature difference or temperature to required to raise the temperature by 1 degree centigrade of 1 mole of substance, of 1 mole of substance. Here what we have considered here, 1 kg. Here 1 kg. Now if the gas is considered a 1 mole of gas, let us say, if that gas is considered 1 mole, now if it is and it is held under constant pressure during the heat transfer, then it is called the molar specific heat capacity at constant pressure, which is denoted by Cp, right? And in the other hand, If it is held under constant volume, at constant volume, then this is called as CV. What is this? Molar heat capacity at constant volume, right? Uh, Coming to the concept of specific heat capacity. So on all comparisons, water has highest specific heat capacity. Water has highest specific heat capacity compared to other substances. Right. So this is a simple reason where, due to this reason, water is acting, or water is used as coolant in the radiators, automobile radiators, coolant, as coolant in automobile radiators. So it is heated very slowly, not quickly, cools down very slowly, right? Automobile rate, as well as heat, and this is also acting as a heater in hot air bags. So, right, due to this particularly high specific heat capacity, what is that? What is a water specific heat capacity? Almost 4186 joule per kg per Kelvin. Approximately sometimes we use 4200, right? So owing this, due to this specific high specific heat capacity, water warms up much very slowly than the land in the summer. In the summer, you see that water cannot be heated very quickly, whereas the surface heats very quickly. We cannot walk without shoe or chappal on the surface during the summer. So where water cannot be heated as like an earth surface. So why this is happening? There is a compulsory, there is a difference of a specific heat capacity of the land surface or earth surface compared to the water, right? And in the particularly desert areas, what happens? Earthworms are warm up very quickly during the daytime, right? And cools very quickly during night time. What is the reason? Think of it. During night time, what is the reason? In the desert areas, like it is like sand surface, in the daytime it can be heated more, night time it is very cool, the sand surface becomes very cool. Do you think that any relation of specific heat capacity with this? Definitely, obviously it plays a role, right? Compare Oil, you can heat the oil, you can heat the water, which cools down very quickly, which one is not cooling down quickly. You can think of it. Definitely specific heat capacity of oil, water are different. Now calorimetry. What is meant by calorimetry is, what is the meaning of measuring heat actually? Suppose, what is isolated system? A system said to be isolated if there is no exchange of heat. If no exchange of heat or transfer of heat occurs between the system and surroundings. Surroundings means environment. System and surroundings. System and surroundings. Right? Here, suppose within the system, when different parts of isolated system, different parts of isolated system are at different temperatures, then what happens? Heat is transferred from one to other. Generally, heat is transferred from higher temperature to low temperature. Heat is transferred from higher temperature to lower temperature, right? And then important thing is that the heat lost by the part at a higher temperature is equal to the heat gain by the part at lower temperature, right? What is meant by calorimetry? Calorimetry is nothing but here measuring heat. However, the heat gain or heat lost will calculate heat measuring heat. Now suppose when a hot body, let us say this hot body is in contact with the cold body, what happens? The hot body will lose the heat and the cold body will gain heat. So the body becomes hot body becomes cool. So both will come to a common temperature, which is called as equilibrium temperature. Now what is the principle of calorimetry? How to write the principle of calorimetry? Principle of calorimetry is heat lost by the hot body, which is equal to heat gain by the cold body. This is a simple phenomena where we use in the problems. Actually. What the condition here? Provided that no heat is allowed to escape to the surroundings, to escape to the within the system surroundings at here within the body surroundings. What is calorimeter? It is simply called as a device which measures which measures heat, is called as calorimeter. Is one, right? Now, how the calorimeter is constructed and what are the contents which are there? See that this is like in a vessel format made up of copper material or like aluminum material or some other material. This is generally used as a copper. This is copper material, and there is one other thing is called as a simple stirrer, which is made up of same material as made with the this one, like this is called as stirrer, which is used to stir the mix the contents, which is called as stirrer, used to stir the contents within are there in the calorimeter, right? Now, of course, there is arrangement of thermometers also there in order to measure the temperature, and there is a wooden jacket around it because to protect the heat from the system to surroundings, not to escape the heat. This is, of course, wooden is a simple bad conductor, wooden plank or wooden jacket, right? This is wooden out shield, outer jacket act as a shield, heat shield, and reduces the heat loss from inner vessel to outer vessel. There is a simple opening of the jacket for thermometer as well as a stirrer, and there is a arrangement of mercury thermometer, right? And in this a cotton type of material or a glass like can be filled, or thermocol type where they are used as bad conductors of heat, where a heat cannot be escaped from this, right? Now, this is simple principle, uh, which is called as heat lost is equal to heat gain. The amount of energy lost is equal to amount of energy gain. This is called as a principle of calorimetry. This is called as a principle of calorimetry. With this, actually, a principle, suppose specific heat of the substances, final temperatures, or unknown parameters can be calculated by making balancing of this. Unknown values can be estimated. So we shall see the problems, then you will come to understand how this is applied.